Hello everyone. Today we are going to explore a fundamental yet often underestimated aspect of operating systems, which is file management. Every time we save a document, install an app, or even boot up our device, the operating system is working behind the scenes to organize, retrieve, store, and secure data through an intricate file management system. Without it, our digital world would be chaotic. So, in this lecture, we'll break down what file management means, why it's essential, and how operating systems handle various file operations. Okay, now let's talk about files, which are the core building blocks of file management. Now, when you use an application, whether it's writing a document, creating a spreadsheet, or designing a graphic, your work is temporarily stored in RAM or random access memory. RAM is super fast, but it's also volatile, meaning all the data in it disappears the moment the power goes out or your system crashes. That's why unsaved work can be lost in an instant. To avoid this, we need to save our work. When you save a file, it's copied to a more permanent form of storage, like your computer's hard drive or a USB flash drive. This way, the data remains even if the system is turned off. Now, the saved work becomes a file that contains not just the content but also metadata like its name, extension, date, time, and size. Now, these elements help the operating system and the user to identify, organize, and manage the file effectively. Um, Now, what is a file extension? Like, it's the part of the that follows the file name. Um, Typically, after a period like .docs, .jpeg, or .abc, it tells the operating system what kind of data is inside and which application should open it. So now let's focus on file names and extensions, which are essential for organizing, accessing and understanding files within an operating system. So as I said earlier, like when saving a file, there are certain naming conventions you must follow. First, let's talk about case sensitivity. Um, in some operating systems like Linux and other Unix based systems, the file names ABC or ABC, like capital ABC or small letter ABC, are treated as completely different files because they are case sensitive. But in Windows, the operating system is not case sensitive, so both names would rather would refer to the same file. So basically in Windows, if you save a file is as capital ABC or a small letter ABC, it's referred to same name file because it's not case sensitive. Now next is the maximum length of a file name. Now on Windows, this is typically up to 260 characters, including the path. So keep your file names concise and meaningful. Um, then we have spaces. Like spaces are allowed in file names, but you should use them carefully, especially when you are dealing with multiple spaces. It can be hard to tell the difference between, say, like two spaces and three, which might create confusion or issues in scripts and file management tools. Next is digit. Digits are allowed, but there's some characters you should avoid entirely, like backslash, forward slash, colon, star, question mark, then like greater than or less than, then or these are either reserved for system use or have special meanings in commands. So now let's revisit file extensions. Like, these are more than just labels. They give valuable clues about what's inside the file. For example, .docs indicates a Word document. .jpg points to an image file, and .exe signals an executable file. So the operating system uses these extensions to determine which application should open the file and how it should handle it. That's why changing or deleting a file's extension can sometimes make it unreadable. Okay, now let's look at some common file extensions, what type of documents they represent, and which applications typically open them. So first we have doc or docs file. These are word processing documents created using Microsoft Word. The docs format is the more modern version, introduced in Office 2007 and later, using XML based formatting. Next we have XLS and XLSX files, which are Excel workbooks used to organize data in spreadsheets. Excel is particularly powerful for performing calculations, managing budgets, and analyzing data. Then we have PPT or PPTX, which are PowerPoint presentation files. These store slides, graphics, text, and transitions, just like the one we are using in this lecture. Now, the ACCDB extension refers to Microsoft Access Database files. So these are used to store structured data, queries, forms, and reports. It is ideal for small to medium scale database applications. Now we have some image files commonly end in GIF, JPG, PNG. Each of these formats has different use cases. Like GIFs support animation. JPEG are great for photos with lossy compressions, and PNGs are perfect for high quality images with transparency. Now these are often opened in using like Windows Image Viewer or any image editing software. For multimedia, we have formats like MP4, MP3, which are used for video and audio. These can be opened in applications like Windows Media Player or modern media apps. Then we have zip file. Zip extension represents a compressed file. Zip files help group and reduce the size of files for easier storage and sharing. Tools like WinZip or built-in utilities in Windows and Mac OS are used to extract them. Then next we have PDF, which stands for Portable Document Format. Now typically it is viewed in Adobe Acrobat Reader. These are perfect for sharing fixed layout documents that retain formatting across platforms. Lastly, we have HTML or HTML files. These are web page files written in hypertext markup language. Web browsers interpret these. Web browsers interpret these to display websites. So we have more also. We also have text file, which is a notepad file that opens in a notepad. Then so we have also some other type of file that allows the operating system to automatically choose the correct application for opening each file. Okay, now by default, Windows hides the extensions of known file to keep things visually cleaner for the average user. However, as power users or students of operating systems, we want to see those extensions because they give us important information about file types and how they are handled by the OS. Now, how do we make these extensions visible? First, we'll open any Windows Explorer window. That's just any folder window on your computer. At the top, choose the Organize tab. This opens a drop down menu. Now, from there, select Folder and Search options. In the dialog box, click the View tab. Now comes the important part. Uncheck the box that says Hide extension for known file types. This single checkbox controls whether you can see extensions like text, docs, or exe. Finally, apply to folders. To make this change, apply system wide, not just for the current folder. Once you have done this, you'll always be able to see exactly what type of file you are working with. This can help you um, avoid accidentally opening harmful executive files, or rename or convert files properly, and better understand what software is needed to open a file. Now let's turn our attention to file systems and how they can relate to drives. Every computer relies on a file system to organize, manage, and keep track of the files stored on it. Without a file system, your data would be just a blob of unreadable bits, like no structure, no order, or no way to find anything. Now, file systems don't exist on their own. They're built on top of physical storage devices, which we call drives. Now, these can be things like hard drives, SSDs, USB flash drives, or even SD cards. The file system is what allows us to read, write, and organize data on these devices. Now, drives can be local, like the C drive in your laptop, or remote, such as a network drive, or cloud based storage like Google Drive or OneDrive. From the user's perspective, they often function similarly, but in reality, remote drives require internet and network connectivity. To view the drives on a Windows machine, simply open My Computer or this PC. You'll see all available storage locations listed, each usually assigned a letter like C, D, or E. You must also see network drives listed there if you're connected to an organization's network. Okay, now that we understand what drives are and how file systems interact with them, let's look at the typical drive letters you will see on your Windows system. Now, as I said, Windows assign letters to each logical drive starting from A. Traditionally, A and B were reserved for floppy disk drives. While floppy drives are now obsolete, these letters remain part of computer history. So C is most always the primary local hard drive. This is where your operating system is installed and where most of your files are stored by default. Then we can have D, like usually the CD or DVD drive, if the computer has one, is referred to D, but today that might be replaced by a virtual drive or external device, because nowadays computer don't have a CD or DVD drive. Then E through Z. These are commonly assigned to removable media like USB flash drives, external hard drives, SD cards, or mapped network drives. The cool thing is, any available letter can technically be assigned to any storage partition or device. For example, you can have multiple partitions on one physical drive labeled DEF and so on. Um, so, knowing these drive letters and their typical uses helps you quickly identify where your files are being stored or accessed. Now, let's see partitions, which are another important part of how file systems organize data or storage. Like a partition is not only physical storage device, it's a logical division of one, but to the operating system. It looks like a completely separate drive. So, one physical hard drive might appear to the user as two or more separate drives, each with its own ladder and file system. So, why is this useful? Like in earlier versions of Windows, there were limitations on the size of storage devices the OS could handle. If your hard drive exceeded that limit, the system could not access all of it. So, partitions were used as a workaround. They allowed the OS to treat one large drive as if it were multiple smaller ones, each within the size limits. Even today, partitioning is still common. For example, a computer might have one partition for the operating system and programs, another for personal files, and the third for backups or recovery data. So that's a sample disk partition, like a visual example of how we can have disk partitions. And so at first glance it might look like multiple hard drives stacked together, but this is actually one single drive partitioned into separate sections, each treated by the operating system as an independent storage unit. Now at the top you have a C bootable partition, often used for installing Windows. Then we have so this is the primary partition labeled as partition 1. Now then we have local drives like D, E, F, which exist inside an extended DOS partition. These are additional volumes used to store files, programs, or even other operating systems. Further down you'll see two uh, two more bootable partitions, one for Linux and one another for OS, demonstrating multi-boot configurations. These are labeled as non-DOS partitions, meaning they don't use the FAT file system standard used by DOS Windows. The takeaway here is that partitions allow a single hard drive to act as multiple drives, each with its own file system and purpose. This structure make it possible to run multiple operating systems on the same machine, organize storage for different types of data, or isolate backups and recovery tools. Okay, so to wrap up things up, let's zoom out and look at file management as a whole. Now, the reason we have all these systems and structures in the first place, the operating system provides a logical and organized way for us to store, retrieve, and manage data through a hierarchical structure. Think of it like a filing cabinet. At the top, you have your drives C, D, E, etc. Within each drive, there are folders. These are like drawers in the cabinet. Inside those folders, you have more folders, also called subfolders, which help break things down into categories. Finally, inside the folders are the actual files, the documents, spreadsheets, images, or videos you're working with. This hierarchy helps both you and the operating system understand where things are and how to access them quickly. We often use storage metaphors like these to help us better visualize and mentally organize the contents of our storage devices. By seeing it this way, it becomes easier to manage large volumes of data without getting overwhelmed. So, here we have a visual example of a file system tree using two devices C and D. So, this kind of diagram helps you understand how the file system organizes data in a hierarchical structure like a tree. So, at the top of each tree is the root directory, which is the starting point for all files and folders on that device. On the C, we see the root directory branching into folders like college and Windows. Under college, there is a subfolder named Fall 2006, which further contains folders for different courses, CS 101, CS 215, and etc. Then inside CS 101, there's a file named chapter01.ppt, which is likely a PowerPoint file related to that course. Now on the D drive, we see a different set of folders, drivers and setup. Now the setup folder contains a file named autorun.exe, which is commonly found on installation media. It runs automatically when the device is accessed. So this tree-like representation shows how files are nested inside folders and folders inside other folders, creating a logical structure that makes it easier to store, locate, and manage data. It also demonstrates that how each drive maintains its own independent tree. Okay, so to help you understand file management more intuitively, we often use metaphors. These simply the concepts and help us relate them to the physical world. Now, one of the most common is the tree metaphor that we just saw. Like the tree have root, then branches, leaves, and on the right side of this slide you can see a great visual of this metaphor. Okay, let's now explore the structure behind how files are organized through directories and folders. Every storage device, whether it's a hard drive, flash drive, or external device, has a directory system that keeps track of all the files it holds. Now, at the top of this structure is the root directory. For example, C is the root directory of the main hard drive on a Windows system. From there, you can have subdirectories, which are commonly referred to as folders. These folders can contain more folders, creating a nested hierarchical system. Now, one important concept here is the path. A path tells the operating system exactly where a file is located. For instance, in D drive, we have D is the root of the D drive. Then if you wanna locate the notes.txt file, this is under C drive, C notes CS101 week 1 notes.txt. It shows a detailed path starting from the root directory. Then again the next one shows another path, this time using drive F, leading to a folder containing music file. So let's wrap up by looking at some very practical reasons for using folders when managing your files. First, folders help with organization. Like when your files are neatly categorized in folders, they're much easier to find. This reduces frustrations, saves time, and minimizes stress, especially when you are on a deadline or working with a large amounts of data. Second, folders allow you to manipulate groups of files more efficiently. You can move, copy, delete, or even email an entire folder of documents at once instead of handling each file individually. Third, folders let you reuse file names. For example, if you have two files named a.txt, as long as they are in different folder, you can use them. This flexibility can be really helpful when working on projects with repeated or templated file names. And finally, using folders doesn't limit how you interact with files. In fact, folders can help organize content that's handled by multiple applications. You might create a spreadsheet in Excel, compress it into a zip file, or create a video file, play it later in Windows Media Player. So, all of these can be managed more cleanly and clearly when files are stored in well structured folder. Okay. Okay, now where is the desktop really? Although it might feel like a special or separate area on your screen, the desktop is just another folder. So, one that's conveniently placed for quick access, like one on Windows system, your desktop lives in C user username desktop. On Mac, it's found at username your name desktop. Now, knowing this path is helpful when you are navigating file locations. So, this becomes especially important in situations like using the virtual DEN or remote desktop environments. If you are working in Microsoft Access or another application that asks you to open or save a file and it defaults to the root of the drive, you will need to manually navigate to your desktop folder using this path. Okay, now a file format refers to the organization and layout of data inside a file. It determines how the data is stored and how applications read and write to that file. Typically, a file extensions like docs, JPEG, or zip tells the operating system and the user what format a file is in and which program is needed to open it. For example, XLSS indicates a spreadsheet created by Microsoft Excel. But here's an important point: changing a file's extension doesn't change its format. For instance, if you rename a file from report.xlxs to report.zip, it doesn't magically becomes a zipped file. The data structure inside the file hasn't changed. You just rename the label. It still behaves like an Excel spreadsheet and won't open properly in a zip program. Now, to truly change the format, you need to convert the file using the right application. For example, use Excel to export or save a spreadsheet as a PDF. Use compression software like WinZip to convert a file to a zip archive. Now, how applications interact with files, especially when saving or naming them. Most applications that create or edit files like Word, Excel, PowerPoint, or image editors, they have a file menu that gives you the options to save as, and rename. So on save, if the file has already been saved once, this will override the current version if you click save. It's a quick way to preserve changes. So if you wanna save it in a new version without changing the previous one, you can save it on a new file. If you haven't saved the file before, the program will ask you to choose a name and location for the file. But then you can use save as. So if you wanna make a copy of your new version, this always prompts you to enter a new file name and it creates a new copy of the file. This is useful when you want to create a version of your file without overwriting the original. Then rename. Now this option lets you change the name of an existing file without altering its content. You can do this directly from the operating system's file explorer or within the application. Okay, now if you look at here, so as you can see, File Explorer is the main interface in Windows that lets you interact with your file system. With it, you can easily rename, copy, move, add, delete any file. So it provides a visual interface that mirrors the file management concepts we have discussed, showing drives, folders, and files in a hierarchical tree structure. So you have my documents, my music, my pictures, my videos. So this helps you organize your data by content type. You can also create subdirectories within these folders to further structure your files. Okay, now let's clarify a common confusion, which is like Windows Explorer is not the same as Internet Explorer. Internet Explorer was a web browser used for surfing the internet. Windows Explorer, on the other hand, is a file manager. It's what you see to browse through your computer's folders and files. So Windows Explorer, now often just called File Explorer, allows you to view files in different layouts like icons, lists, or details view. You can choose whichever view makes it easier for you to manage. It also shows a variety of file information, things like file name, type, date it was last modified, size, and more. You can customize these by turning on the menu bar, going to the view menu, and selecting choose details. Now, most importantly, it provides a graphical user interface, which means you can drag and drop files. Okay, now to understand how data is stored and transferred, we need to understand the units used to measure file sizes. Now let's start small. 1 byte stores one character, like a letter or number. It's a tiny unit, but it's the building block of all data. 1 kilobyte is 1024 bytes, enough to hold roughly a page of text. 1 megabyte is 1024 kilobytes, about the size of 1000 page book. 1 gigabyte equals to 1024 megabytes, or over a billion bytes. That's roughly the size of a library filled with 1000 books. Then terabyte and petabyte, so these are like million libraries worth of information. So these measurements helps us understand file sizes, storage limits, and how much space we need for things like backups, photos, videos, or system data. Now that we've looked at the different units of measurement for file sizes, let's go a step further and talk about how these units relate to each other mathematically. If you already know that, that's good, but if you don't know, let me just go through it. First off, we have 1024. Now 512 into 2, or 256 into 4, or 128 into 8. This helps us understand how units stack up in powers of 2, which is important in computing. 1 gigabyte equals to 1024 megabytes. Therefore 0.5 gigabyte is equal to 512 megabyte, and 0.25 gigabyte equals to 256 megabyte. Let's apply that to a real world example. Now if you have 512 megabyte files and a 2 GB memory stick, would they all fit? Now first convert 2 gigabyte to megabyte. If we convert it, now we have 2048 megabyte. Now calculate the total file size. It will be 7 into 512 megabyte, which means 3584 megabytes. So no, the files would not fit. You'll need 1536 megabyte more space, which is roughly like 1.5 GB more. And this type of math is critical when managing storage, planning file backups, or even buying the right size flash drive or cloud plan. Okay, now every file on your computer contains data which is stored as a sequence of bits, the smallest unit of digital information. That data adds up to give us the file size, which tells us how much storage the file occupies. File size is typically measured in bytes, kilobytes, megabytes. This gives us a way to compare and manage files. For example, a text document might be 24 kilobyte, while a media file could be several hundred megabyte or even gigabyte. Alongside the size, files also have dates, usually the date the file was created and the date it was last modified. These are displayed in tools like Windows File Explorer, as you can see in the image. Um, these timestamps are useful for tracking progress on documents, finding the latest version of a file, or identifying when a file was last accessed or changed. Okay, now let's take a more practical look at why file sizes and file dates matter in everyday use. So, why is file size important? Your memory and storage capacity, whether it's hard drive, USB stick, or cloud storage, it helps answer questions like how many songs can I fit on my MP3 player? How many photos will my camera hold? Did all my data actually get saved? Or a very common scenario, did I submit a file for the lab test that was empty? File size can be a quick clue. Why is file data important? Date, sorry. So dates help track the history of file creation and changes. Like you can quickly see which version of your paper is the most recent. And very importantly for students, did I submit my lab test on time? So knowing how to check and interpret file size and modification dates isn't just useful, it can save you from major mistakes. Okay, as we near the end of this session, let's go over some practical file management tips that can save you a lot of time and stress. First, try to not store too many files in the root directory. While it might seem convenient, it can actually slow down access and make it harder to find what you need. Instead, use folders and subfolders to keep things organized. Next, always follow copyright rules. Like don't store or share copyrighted materials unless you have permission or the proper rights. This applies to music, software, documents, and more. Also, make it a habit to delete or archive files you no longer need. It clears up space and helps you keep your file system uncluttered. Now, be aware of where you are saving your files. Now, this one is critical. If you don't know where your file is, you won't be able to submit it. Like, I can't tell you how many times students say I did the assignment, but I can't find it. Now that's not going to help when it's time to turn it in. So always pay attention to your storage locations, and last but not the least, make backups, whether it's a cloud drive, external USB, or email to yourself. Having a backup can be a lifesaver when you maintain your device, like when your main device fails or something gets accidentally deleted. Okay, now when you zip a file, you're actually compressing it, like removing redundancies in the data to make the overall file size smaller. This saves space and speeds up tasks like uploading, downloading, or sending files via email. Now, zipping also archives the files, meaning you can take a whole group of files and combine them into one single file. So, the zip file format was created by Phil Katz in 1989, and it remains widely used today, supported by every modern operating system. Okay, now our last topic is something you see all the time on your desktop or in the folders, like shortcuts. A shortcut is simply an icon or file that points to another file, folder, or application. It's a quick way to access something without having to dig through layers of directories. When you double click a shortcut, it's the same as double clicking the original file. It launches the program or opens the document it's linked to. But here's the important part: the shortcut is not a copy of the file. If you move or delete the original file, the shortcut won't work anymore. You'll get an error message saying it can't find the file. So this becomes especially relevant when you are submitting assignments or lab tests. If you send your TA or instructor just a folder full of shortcuts, they won't be able to open anything unless they also have the original files in the same locations on their system, which they won't. So, um, the takeaway here is shortcuts are for convenience on your own device, not for transferring or submitting actual content. Okay, so that's all for today's lecture. Let me know if you have any question. Thank you.